Good afternoon. My name is Komojo Samuel Zulu. My student number is 68196504. The title of my project is Smart Room Temperature and Light Controller. In this project, I designed a simulated microcontroller based system that automatically monitors a room temperature using LM35 sensor and measures ambient light using LDR sensor. According to these readings, the system intelligently controls a fan and an LED lamp while displaying the temperature, light level, and system status using the LCD screen, which is 16:2. The system works as follows. The LM35 measures temperature. The LDR sensor measures light intensity. These signals goes to ADC 0804 and the multiplexer, which is 74HC4051. And then the 8051 microcontroller reads the digital values and makes decisions. The LCD displays temperature, light level, and a mode. If temperature is above 30, the fan turns on. If the room is dark, the LED turns on. A push button allows switching between automatic mode and manual mode. The AT89C51 microcontroller, it works as the brain of the system. And then the LM32 temperature sensor is connected to the multiplexer and the ADC to convert the analog value. The LDR is also connected to measure light, and the ADC0804 converts the analog signal to digital for the microcontroller. And the multiplexer, which is 74HC4051, allows us to switch between the LM35 and the LDR inputs. And then the display, which is 16:2, displays the temperature, the light level, and the mode status. Whereas the fan represented by the motor DC and is driven by what? The transistor. The LED is also controlled by the resistor, which they are connected in series. The reason why we are connecting the transistor here is because this motor needs more current, and this can provide the CPU can provide the adequate current. So that's why we are using what? The transistor to boost the motor to run. And then we also have the lamp here, which is controlled by the resistor. We also have the push button, which switches between the automatic and the manual mode. I wrote the program in an embedded C using KU Vision, which I'm gonna show you how I use the program. I'm gonna start a new project. And then I'm gonna name it as my student number, which is 68196504. I'll name it project number 1, MCD2601, and save. Then I'm gonna use the 8089C51. Here it is. Yes, and I'm extending it. As the new group source, and I'm gonna use the C type, and I'm also gonna name it as 68196504. Project 1, MCD 2601, and I'm gonna add it. And now I'm gonna write my program here, which is, I'm gonna just copy it and paste. Because I've already prepared it. Here's my program. I'm gonna just copy, enable the editing. Use it here and check. Here's the hex that I've created. Say okay. Then I'm gonna come and simulate. Yes, now you can see the screen displays an off LED and an off fan. I'm gonna start with the automatic one. I'm gonna increase my temperature on the LDR. I'm gonna start with the temperature to monitor my fan. You see, even the temperature on the screen does increase. Remember, the fan will only start turning when the temperature is above 30 degrees. I'm gonna keep on increasing. On the screen, the temperature is also increasing. After 30 degrees, that's when the fan will start turning. And you can see my LED is off. I'm also going to turn on my LDR to increase the light intensity to monitor this lamp, the LED lamp, which is purple, which is gonna turn purple when the light goes up, when the intensity of the light goes up. Let's increase the intensity. It also turned on. It also going to below 35 is gonna be off. Let's see. It's off below 35, and let's go up again. Increase the intensity. It goes above the threshold. That's why it's turning on. Now we were using an automatic. As you see here, we've got an auto which we've got an A which displays for an auto, which symbolizes an auto. Then we're gonna go also to a manual. Let me switch off the fan so we can also monitor the fan through the LM35. We are decreasing, will decrease. If you see, if you check here, when we decrease the temperature, the fan will automatically turn off. You can see the speed of the motor, it's also going down. As much as we are going down, we're taking down the temperature. We're taking down the temperature. Also, the speed reduces up until it goes to 0. It will come to a definite stop. And monitor it and see. Let's take everything to 0 so we can do the manual one, the manual simulation. The fan is totally on and stop. It's going down. Stopping. It's coming to a stop. Now we're gonna go for a manual simulation whereby we're gonna use the toggle switch. We need to change as well the automation, the symbol of auto here to a manual operation whereby we wanna use the switch. It's now, if you check the motor, it's turning. Our LED is also on, turned on. You can see we are no longer using the automatic operation. We are on manual by using the switch. Let's switch it off and see if everything will even if the motor will turn off, even the LED will also turn off. We turned it off, the LED is off, and the fan will come to an absolute off, absolute stop, because we turned off the power. So in conclusion, the sensors respond accurately, the fan and the LED in real time. The LCD displays all information clearly. The mode switching works perfectly. One challenge I faced was controlling two analog sensors with one ADC, but I solved it by using 74HC4051 multiplexer. I also had to carefully adjust the transistor circuit to make sure the LED was always on.